Assalamu alaikum and good evening, everyone. Today we are going to have lecture number 11. In this lecture, we are going to talk about how to use the libraries, especially the math library. A library is a collection of pre-written code that can reuse, that we can reuse. So instead of writing everything from scratch, Python provides libraries for different functions such as math calculations, graphics, data analysis, machine learning, AI, etc. Example of the libraries available are math library that provides functions for real number mathematical operations like trigonometry, logarithms, and constants. Similarly, another very widely used library is the matplotlib.pyplot, which is used for plotting graphs and visualizing data. Similarly, cmath library is used for mathematical operations involving complex numbers, and numpy is advanced mathematical library. So today we'll talk about the math library. Python provides a built-in library called math for mathematical operations. A math library is a built-in Python module that provides the logarithmic functions, trigonometric functions, constants such as pi, re, etc. So let me quickly write these things and then we start how we can use these libraries. So these are the brief overview of the lecture. So let's start with how we can use the libraries such as math library. So to use math library like math, we need to import them. Okay, so how to import a library? So to import a library, we use the keyword import followed by the library name. For example, I write import and I write math. Now, what does this function do? It will import the math library. So let me run it. So that's how we import them. Now, after importing this one, we will use the functions that are provided inside this math library. So to use the function inside this math library, we use the dot notation. So for example, to use the power, I will write math dot power. So let's start with the power function inside the math library. So I will just write, for example, A is equal to math dot POW. Now the POW, we have the base function followed by the exponent. So for example, I have 2 power 3. Now it will find 2 power 3. So let's print this value. So print A will give me 2 power 3, and you understand 2 power 3 is basically 8, and you should know that these return the float value. Similarly, if I want to calculate, for example, the square root, so I can write, for example, B is equal to math dot power. So I can find the square root of something. For example, 16 is 16 power 0.5. So you understand the 16 is the base and its power is 0.5. So 0.5 means the square root. Okay, so let's see this one. I'll just write the print and B. So it will give me the result. So you understand that 16 power 0.5 is basically 4, or 16 power 0.5 is the square root function, right? So we can also use another function inside this math library that is called square root, or sqrt. So let's say I say C is equal to math dot sqrt, and then I write the function the number whose square root is to be found. Okay, so I'll print this one. So I'll write print C. Okay, so hopefully you understand that this one, math.power and math.square root, it produces the same value. So hopefully you understand that to import library, we use the keyword import, and you see its color is changed. So import math means it will import the math library. Inside the math library, we have different functions such as power, square root, log, and so on. So this is about the power. So let's talk about the next function, that is the log function. So you understand we have three different types of logs, right? So we have log, natural log, right? Where we have base of e. We have the general log, that is the log of this one, log of 10, which has base of 10. And similarly, we can also have the custom base. So log with custom base. So let's do few examples on all of them. So let's suppose we have D equals to, for example, 150. Okay, or maybe let's restart. A equals to, maybe D is okay. Okay, so we have D equals to 150. Now I want to take the log of this one. So log of this one, how I can take, I will write the function inside the math library. So let's find the log. So as we have discussed, there are three types of logs. So let's start with the first one. So I say E equals to math.log, and I write D. Okay, and then because E is keyword, so let me denote by, for example, EE. So when I run this one, I get this one. Now I want to print, so print EE. Okay, so EE is basically log, a natural log of the 150. So this is this one, right? Again, if I want to take the log to the base 10, so I can write, for example, EF is equal to math dot log of 10, and then I write 150. So this gives, let me print this one. So print EF, right? So EF is basically the log of with to the base 10. Similarly, if we talk about the third one, the custom base, so let I say that EG equals to math dot log. Okay, and then I specify here the number whose log is to be taken, that is D, and what base I want to select. So for example, I want to select base 2. Okay, so you understand this one is natural log or to the base E. This one is the log to the base 10, and this one is customized. So you can take 2 or any other thing. You understand the custom base. So base can be any. Okay, and then I say, okay, print EG. Okay, so let's run it. So you see that the first one is, we have the number D that whose log is to be taken. So that's equal to 150. So if I take the log of 150 to the base E, it will give me 5. If I take the log of 150 to the base 10, it will give me 2.17. And similarly, if I take the log of this one to the base 2, okay, so it will give me 7.228. So hopefully you understand how to take the log, and you understand there are different logs. So that is to the base E, 10, or custom. Let's see how we can take the anti-log of these. So again, we have, for example, let's take those same values. So I say E, G, E, H equals to. Now to take the anti-log of natural log, we'll have math.exp, and here we write the EE. Okay, so I'm just doing the reverse order. That means the anti-log of EE should be equal to 150. Okay, so again, I say EJ equals to, this is straight away, because anti-log in case of base 10 is straight away 10 power that thing. So that will be EF. So it gives me the anti-log of 10. Similarly, EK is equal to, now if I take the anti-log of the custom base, I will use the power function. So math.power, and you understand the first one is basically base. So the base is basically, here we use the base 2, so I will use this one. And then here I will use the exponent, which is EG. Okay, so let's print these. Print EH. Okay, so this one is EJ and this one is EK. So if I run it, so you see it gives me exactly the opposite of what we had, right? So 149.99 is roughly equal to 150, again 150, and again 150. So we end the lecture here, and we have some uh, homework. Okay, so this is for your homework, right? Find anti-log of 1 to the base E. Similarly, these are all based on the anti-log. So you can practice with this one. Today we covered the exponent, logarithms, and anti-log functions using Python's math library. So hopefully you understand how to use the library. To use any library, you write the keyword import and that library name. And inside those libraries, we have different functions. So to access those functions, we use the dot notation. So for example, import math, then we use import math.pow. Then we provide its input argument. So make sure you try the homework questions yourself, especially the anti-log calculation. It will really strengthen your understanding. In the next lecture, we are going to move one more step further and learn how to work with trigonometric functions like sine functions, how to find the sine function, cosine function, and tangent function in the Python. If you find this lecture helpful, don't forget to like, share, and subscribe. See you in the next lecture. Goodbye.